Okay, welcome. This is the road from Java to Groovy. So I know it's a Groovy conference, and probably a lot of you have already made this journey, but there might be some tricks in here that you were not aware of, and you want to be paying attention to if you're bringing code over from Java. A little bit about me. So I flew as my first career, 20 years or so, and then software since then. Worked on the space station, and am now currently not on the space station, but on the project, and got into Java and have been riding that wave all the way through. I'm currently on the OCI Grails team. So there's a little legend here, right? So the green light means really easy, straightforward. You just rename the file and you're ready to go. The yellow little cautionary notes we have to make, and then there's a couple of red lights that we have to be aware of that we just cannot, we have to do some rework because it just won't work in Groovy. An additional legend is if you see a parrot, then I'm telling you that the inconsistency that we have in Java, moving from Java to Groovy, is currently an inconsistency in Groovy, but the new parrot grammars that are going to come out in version 3 of Groovy take care of that and won't be a problem anymore. So generally the migration's pretty easy. Often we just rename the file and it works. There are a few roadblocks and detours that we'll be examining now. For instance, in Groovy, in Java 8 they introduced default methods into interfaces. So we have this notion of a functional interface. It has a single abstract method, and now we can put behavior with a default method inside of an interface, and unfortunately, Groovy will not support that today, and I'm not sure if the parrot grammars are going to take care of it. But we do have traits, and they're kind of like Java 8 interfaces in the sense that we can put behavior on there, but they're kind of like classes too, because we can also have state, which you cannot have a mutable state in a Java 8 interface. And so since we can have both state and behavior, we get really the best of both worlds. And the real nice side benefit is that traits are compile time. So whatever you do, whatever behaviors you have, whatever state, what fields you have or whatever, they get compiled into the bytecode. And Java programs calling into Groovy can use those methods and access that state as well. Java 8 also introduced streams, method references, and lambdas. And we see an example of a method reference here, line item : get sale amount. That's a Java method reference. And then we see here this sum sale amount with the arrow. That is a lambda expression. And unfortunately, Groovy doesn't support lambdas and Java method references, but we do have our own method reference mechanism, which we'll see in a little bit. Now, the nice thing is the parrot grammars are going to support lambda expressions. So when Groovy 3 comes out, or maybe some options with 2.5, we'll be able to write Java lambda expressions directly in our Groovy code. Now, how do we get around some of these gaps currently without the parrot grammars? So we have to keep in mind that Java 8 method references are kind of a shorthand for lambdas. And lambdas basically are an implementation, a syntactical sugar implementation for functional interfaces. So the compiler sees the lambda and says, well, this lambda is being passed in for an argument of a particular functional interface type. Java will compile that implementation in. So it all works. Well, Groovy closures can be coerced into meeting the contract of a functional interface. So that means wherever you see a Java 8 method reference or a lambda expression, you can just replace it with a closure, and Groovy will coerce it in to meet that functional interface requirement. So it works. Now it's mostly smooth running, as I said. We often rename the file to Groovy. We have some workarounds. We can use closures to work around the Java 8 gaps that currently exist. The other thing that we can do is we can use AST transformations. AST is abstract syntax tree. We can use these transformations and they affect our code at compile time. So whatever changes they make happen at compile time, and so this supports interop with Java. For instance, if you bring over a Java program and it has this big hairy equals and hash code implementation because there's a bunch of fields or whatever, you can replace that with the AST at equals and hash code, and then get rid of a lot of that code. And since it's at compile time, all the Java classes that make calls into that class will still see the same equals and hash code. Now this one is a cautionary note that you really have to be aware of, that this is just baked into the language, and parrot grammars are never going to solve this. So when we look at this, we see we have a string object assigned to a variable of object type. In Java, at compile time, the compiler looks at this and says, oh, well, I have an object, so I have two methods do something. One's a string and one's an object, and it's declared to be an object, so I'll call the do something that passes in, that takes the object argument. But when we look at Groovy, Groovy doesn't decide which method to call until runtime. And so when this happens with Groovy, by the time we get to this execution of do something, Groovy says, what do I have here? Oh, I have a string. It's going to call the do something that takes a string. So this is a very subtle side effect that, as a result of the dynamic method dispatch that's happening. And so what you're going to have to watch for is if you bring over a Java class that has a bunch of overloaded methods, be sensitive that this could have some implications from a Groovy standpoint. And we'll talk about the compile static and AST later, but that bypasses the dynamic method dispatch and so solves part of that problem. Now, equality is different in Groovy. Equals in Groovy means this. It's a little more complex, right? It means if the thing on the left, in this case the A, implements comparable, then call the compare to method. Yeah, that's kind of interesting, right? And if it doesn't implement comparable, then use its equals method. But in either case, don't compare references, object references, actually compare either using compare to or equals. This little operator is a spaceship operator. If you've never used it, it also basically means call the compare to operator. Now Java, x equals y means is x the same object reference as y? So we don't use that a lot in Java, but there are certain edge cases where you're maybe doing something where you're comparing object references a lot. If you bring that code over to Groovy, remember you're not going to be comparing object references now. You're going to be comparing the actual either compare to or equals result. Now with the parrot grammars, we get the triple equals back. Back when I started with Groovy, 6-7 years ago, maybe it was 7 years ago, we had triple equals, and then it went away, and now it's coming back with the parrot grammars. And so in Groovy, if I want to compare whether A object reference is the same as B, today I would say A dot is B. But when the parrot grammars come out, I can say A triple equals B. So that'll be nice. Now, why is Groovy so slow? This is another cautionary thing. You bring this code over, you rename it from .java to .groovy, you get rid of all the semicolons, and you say, okay, I'm ready to go. And you put it into production, it's like really slow. And the question is, well, why is this so slow? Maybe it's doing, recursion across a big node hierarchy or something, and it just really takes a lot longer than it did in Java. The reason is because Groovy makes that dynamic method dispatch decision at runtime, and it goes through this whole flow chart to figure out what the method is that should be called. And so that slows things down terribly. Well, we can get on the Autobahn and go a little faster with this by using the @compile static. So with this, it bypasses the Groovy meta-object protocol, that whole flow chart decision. And it just basically does a hard wire in at compile time to say, well, whoever calls this method, I'll just hardwire it in right at compile time, and it goes a lot faster. So in this Fibonacci case, I have a slow Fibonacci method and a fast Fibonacci method, and I see what 30 is going to be. They both come up with the same value, but the fast one does it in 7 milliseconds, and the slow one takes 19 milliseconds. So that's a huge performance difference, right? And if you're doing a recursive thing going through thousands or hundreds of thousands of nested nodes or something, you definitely want to try to use compile static to leverage the performance. And the performance is as fast or faster than Java. It's weird, but I have actually seen several cases where it comes in faster. So, a couple of cautionary tales. We've had the issue with our we had the issue with the Java 8 stuff, but we can work around that because Groovy closures allow us to coerce our closures into the functional interfaces. We can work around the equals equals. You're going to have to find those, right? You're going to do a text search for equals equals and then replace it with the .is call or the triple equals when it's available. But there are a few things that you just cannot work around. One is the do-while loop. Groovy does not have and has never supported the do-while loop. And so if your Java code, and we don't use do-whiles a lot, I probably have written 2 or 3 of them in Java the whole time I've ever done Java for like 20 years. But occasionally you have that case where you need the semantics of do-while. And do-while is different than while. How? Well, a do-while, we always execute the loop at least once. We always enter the loop at least once, and a while we evaluate the condition first before we enter it at all. And so it's a subtle difference, but occasionally you need that. If you've got code like that, it's not going to compile in Groovy. And the reason is in Groovy, do curly brace, close curly brace, looks like I'm saying do and then passing a closure, and it's like I don't know what to do with this, so it doesn't work currently. And it's never supported the do-while. But the parent grammars are introducing do-while. For the first time, Groovy will have do-while, and this will go away as soon as we get to Groovy 3. Types and promotion. Another very subtle thing happening here. Again, notice overloaded methods. And so we see int 5 equals 5. In Java, int's a primitive. 5 gets assigned to that. And then when we run this, output in Java, we end up calling the long. And the reason is in Java, promotion occurs before autoboxing. But in Groovy, all of our types are object types. So even though we've declared it as int 5 equals 5, it's really integer 5. So it's really an integer type. And so when Groovy makes the method call, it sees that there's an exact match for integer. So Groovy will call the integer method, but in Java, it'll call the long method. Another very subtle inconsistency that you have to be aware of. So what's the signature here? It's the incompatible type. It's the overloaded methods, and so you get this either with early or late method dispatch or with type promotion. Another collision, you just cannot. We will not fix this. We'll probably never fix this in Groovy, right? There are 4 keywords in Groovy that don't exist in Java. And one of them we use a bunch in Java if you do file I/O. How many of you who've done Java programming use in, like file input stream in, right? Well, in's a keyword in Groovy, so that code's not going to compile. Trait's a keyword, as, def, and in. So if you have those, you have no choice but to go through and sweep through and rename those variables. In summary, migration from Java and interop with Java is almost trivial. But the places where we get bit are a few Java 8 things, but some of the method dispatch and overloaded method things, and we can work around those, but be very sensitive when you have overloaded methods. Very few issues are irreconcilable, but some are like the keywords. Those are just never going to get fixed because those are keywords, and you're just going to have to search through the Java code and get them fixed. Here's some resources, this slide deck. There's also a full talk. This actually is done with a larger talk with lots more code examples. You can get those from slides.com. And also there's some code examples that go with this. This comes from the Groovy Lang docs differences. And if you're interested in the parrot grammars, Daniel Sun GitHub site is where you can learn about those and what's coming up. There's a lot more than I mentioned in the parrot grammars, but they're not applicable to the talk I have. Follow me on Twitter or LinkedIn and email me if you have any questions. That's all I have. Thanks.